Hello everyone, welcome to my YouTube channel. I am Harshita from Sri Venkateswara College of Engineering. In this video, let us discuss about different generation in computer, changes in the process architecture, process operating speed and the bits of operation. First, let us see the introduction. Computers have evolved through different generations, each marked by advancement in process technology. The process is the brain of the computer responsible for the executing instruction and performing calculation. Understanding the different generation of the process is crucial for grasping the evolution of computer technology. Let us see the different generations of computer. First generation, it has evolved in 1940s to 1950. It has a vacuum tube processor. The first generation of the computer used vacuum tubes as the primary component in their processor. Vacuum tube processors were large and generated a significant amount of heat. Despite their limitations, vacuum tube processor laid the foundation for the modern computing. Next, let us see the second generation. It has been evolved in 1950 to 1960s. It has a transistor processor. Transistor replaced vacuum tubes in the second generation of the computer, leading to small, more reliable processor. Transistor processor were faster, more energy efficient, and marked a significant advancement in computer technology. The second generation witnessed the development of high-level programming language and operating system. Next, let us see the third generation. It has been evolved in 1960s to 1970s. It has an integrated circuit processor. Integrated circuit processor was smaller, faster, and more cost effective than their precedents. The third generation also saw the emergence of mini computers and the time saving systems. Next, let us see the fourth generation. It has been evolved in 1970s to 1980s. It has a microprocessor technology. The fourth generation introduced a microprocessor which combined the CPU, memory and the input-output function on a single chip. The fourth generation also saw the development of graphical user interfaces and the birth of the internet. Microprocessor technology paved the way for the personal computer revolution, making computing more accessible to the masses. Next, let us see the fifth generation. It has been evolved in 1980s to 1990s. That is, it has a RISC processors, reduced instruction set computing. RISC processor emerged in the fifth generation, focusing on the executing simple instruction quickly. RISC processor were highly efficient and are found in a wide range of devices from PSCs to the supercomputers. The fifth generation also witnessed the rise of parallel processing and artificial intelligence. Next, let us see the introduction to the processor architecture evolution. Processor architecture has undergone significant changes over the years to improve performance and the efficiency in a computer system. These changes have been drawn by advancement in technology, increasing demands for processing power and the need for energy efficient computing. Next, let us see the transmission from single core to multi-core processor. In the past, processors were predominantly single core, limiting the ability to execute multitasks simultaneously. The multi-core processor distribute workloads across the multi-cores, allowing for better multitasking and improved performance in demanding applications. Next, let us see the adoption of reduced instruction set computing, RISC architecture. RISC architecture simplifies processor design by using a small set of instructions that can be executed quickly. The shift towards RISC architecture has been drawn by the desire for faster and the more efficient processing in the modern computing environments. Next, let us see the introduction for the processor operating speed and the bit of operation. The processor operating speed and the bit of operation are the key factor that determine the performance of the computer process. Process operating speed refers to the clock speed at which a process can execute instructions. Bits of operation refer to the number of bits that a process can process in a single operation. Next, let us see the operating speed. The process operating speed is measured in hertz and indicates how many cycles per second a process can execute. A higher operating speed typically result in faster processing and better performance. Overclocking is a technique used to increase the operating speed of the process. Next, let us see the bits of operation. The bits of operation in the process refer to the width of the data bus and the register. Common process architecture include 32-bit, 64-bit and 128-bit processor. Next, let us see the real-world application. Processor operating speed and the bits of operation play a crucial role in various applications, including gaming, multimedia editing, and the scientific stimulation. High performance processor with fast operating speed and the high bit of operation are essential for the demanding tasks such as video editing and 3D rendering. In gaming, a faster processor with a high bit count can improve frame rates and the overall gaming experience. Finally, I conclude that the evolution of the computer processor have been marked by continuous advancement in performance, efficiency, and the abilities. Process architecture continues to evolve to meet the increasing demands of the modern computing application. Process operating speed and the bits of operation are critical factors that determine the performance and the capability of the computer process. Thank you for watching this video.